I want you to picture a crocodile. But this isn't, from some nature documentary. It's not lurking in a swamp.
Okay.
This crocodile is carved onto the stone facade of a physics lab in Cambridge. It's shown moving forward. It looks aggressive, ready to just snap its jaws on anything.
Right.
But there's a flaw, a really tragic, almost cruel flaw in its design. This crocodile, it can't turn its head.
So zero peripheral vision.
Absolutely none. And if you look closer, it's lost its teeth. It's swallowing everything whole, these massive chunks of reality, but it can't digest a single bite.
That is a vivid and, frankly, a slightly disturbing image to kick things off.
Yeah.
Sounds like a creature from a nightmare. I'm assuming we aren't discussing cryptozoology today.
We are not. That toothless crocodile is the central metaphor for the deep dive we're taking today.
Yeah.
We are looking at a really provocative bilingual manifesto.
Bilingual?
Yeah, it's titled On Nature and Against Method, or in the original Turkish, Doza Üzerin ve Yönteme Karşı. The whole premise is that modern science has become that crocodile. Blindly moving forward, consuming massive amounts of data, publishing endless papers, but understanding almost none of it.
It's a bold claim.
Mm-hmm.
And usually when you hear people criticizing the scientific establishment, it's coming from, outside the walls, people who maybe don't grasp the rigor.
Right.
But what makes this text so fascinating is that it's an insider critique. This is coming from inside the house.
Exactly. We need to establish the credentials here because the author, Burak Cem Coşkun, he isn't just throwing stones from a safe distance. He's walking right through the fire.
Not at all.
Yeah.
Coşkun is young, born in Istanbul in '94, but his academic pedigree is, well, it's serious. He's an honors graduate in physics engineering from ITU.
Okay.
He's done research on neutron stars and nuclear physics at the Royal Institute of Technology in Sweden and studied theoretical astrophysics in Bonn. He speaks the language fluently.
But he also speaks another language entirely. He's a published science fiction author. He wrote books like Kusur and Işık Getiren. He even translated Richard Feynman's graphic novel into Turkish.
So you have this collision.
Yeah, a collision of high-level theoretical physics and this deep, creative narrative impulse.
And that duality is really the engine of this manifesto. It's laid out in 40 propositions. Roman numerals, I threw XXXX.
Yeah.
It reads less like a dry academic paper and more like, I don't know, a punk rock version of Newton's Principia.
I like that. In fact, Professor Güncel Önkal, who wrote the foreword, he describes it as a bold challenge to the barren suffocation of our age.
Barren suffocation.
Wow.
That sets the tone pretty clearly.
It does. So our mission today is to walk through these 40 propositions. We're going to unpack why Coşkun thinks academia is broken, look at a mind-bending theory he calls the Rose Postulate.
The one that says biology and stars are the same thing.
Exactly. And finally, look at his Ionian dream for fixing it all.
It's a journey from the subatomic to the philosophical, so yeah, we should probably pace ourselves.
Let's start with the critique. The crisis in academia. In Proposition 2, he just draws a line in the sand. He says there is a massive difference between being a physicist and someone who just works in a physics department.
It's the difference between a vocation and a job. He argues that 2,000 years ago, being a physiologos, a student of nature, that meant you were obsessed with the why of the universe.
It was a whole state of being.
A philosophical stance, yeah. Today, he argues, the academic structure is so rigid that thinking is secondary to just fitting in.
It reminds me of the music industry. You have true artists and you have session musicians. One creates and takes risks. The other just plays exactly what's put in front of them perfectly.
That's a great analogy. And Coşkun is arguing we have way too many session musicians in science right now. In Proposition 14, he attacks what he calls fashionable science.
Fashionable science, like trendy particles.
Essentially. He points out that scientists are often forced into opportunism. To get tenure, to get grants, you have to publish. Constantly.
So you join these massive collaborations.
Thousands of names on a single paper, and you just churn out data that confirms the models everyone already agrees on. Like the standard model in particle physics or the lambda CDM model in cosmology.
And for those listening who aren't cosmologists, lambda CDM is basically the standard Big Bang plus dark energy plus dark matter recipe we use to describe the universe, right?
Correct. It's the consensus reality. And Coşkun is saying instead of challenging this recipe, scientists are just frantically measuring the ingredients over and over again to add more decimal points.
They aren't cooking anything new.
No. They're coloring inside the lines because that's what gets funded.
Which brings us right back to that crocodile. The story in Proposition 8, that's actually historical, isn't it?
It is. The crocodile was described by Robert Oppenheimer, of all people, referencing a carving on Peter Kapitz's lab. The crocodile represents science. It has to move forward. It has to devour the unknown.
But Coşkun flips it.
He flips it completely. He says, yes, we are moving forward. We are publishing more papers than ever. We're eating data, but we are toothless. We aren't digesting it into wisdom.
And why? Because we're afraid to look sideways.
Because looking sideways gets you fired, or at least ignored. And this leads to his call for anarchy.
I have to say, seeing science is by nature anarchic, as Proposition 6 was, refreshing. But to play devil's advocate, isn't anarchy a bit dangerous in a field that relies on precision?
He's channeling giants here, like Richard Feynman and Paul Feyerabend. Feyerabend famously argues for epistemological anarchy. The idea isn't chaos.
It's not just blowing things up for the sake of it.
No, it's that the scientific method shouldn't be a straitjacket. True progress often comes from what he calls counterinductive methodology.
Which means what, in plain English?
It means doing the exact opposite of what the data currently suggests. It means looking at a perfect theory and saying, I bet this is wrong, just to see what happens. It's challenging the rules of the game while you're playing it.
He uses a brilliant metaphor for the opposite of this, the golden retriever.
Proposition 7, it's biting. He says a well-trained academic mind is like a golden retriever. It listens to the voice of reason. It sits, stays, fetches. We praise it for being a good boy. But Coşkun points out that the voice of reason is just the voice of the master, the current consensus. It's not some absolute truth.
So if you want to discover relativity or quantum mechanics, you can't be a golden retriever. You have to be, what, a wolf?
You have to be willing to bite the hand that feeds you. He says science needs anarchist movements to break the stagnation. He argues that we have domesticated our thinkers.
But again, isn't that structure there for a reason? To keep us from chasing every crazy theory that pops up? If everyone is a wolf, don't we just get noise?
That's the standard defense, for sure. But Coşkun's point is that we've swung too far the other way. We're so safe, so rigorously checked, that we're just refining the map of the known world.
We're not sailing off the edge to find new continents.
Exactly. We are optimizing, not discovering.
Speaking of new continents, let's pivot to the hard science part. Because he doesn't just complain. He drops a theory that tries to rewrite how we see reality. He calls it the Rose postulate.
Proposition 7. This is the heavy lifting. ROSE stands for Randomly Organized Structural Entities.
It sounds a little like a government agency. What does it actually mean?
It does sound a bit bureaucratic, doesn't it? But it's actually about geometry. The core idea is this. Standard physics tries to explain the universe by looking at forces. Gravity, electromagnetism, the nuclear forces.
Right, the fundamental forces.
We think of them as the rulers of reality. Coşkun says, no, look at the topology.
Okay, topology. We should probably define that clearly. It's the study of shapes, but it's more about their continuous properties, right? Not their exact size.
Exactly. Think of it as the geometry of connectivity. The classic example is that a coffee mug and a donut are topologically the same because they both have exactly one hole.
You can squish one into the other without tearing it.
Precisely. Topology studies those fundamental properties, holes, connections, surfaces, that don't change when you stretch or bend things.
So Coşkun is arguing that reality is defined by these topological behaviors, and they're independent of the physical forces.
Yes, and he proves it with a comparison that, honestly, it blew my mind. He compares a biological cell to a neutron star.
This was the moment I had to pause and reread. Walk us through this, because on the surface, those two things have nothing in common.
Okay, let's visualize it. Zoom in on a basic eukaryotic cell. Look at the endoplasmic reticulum. It's this folded, sheet-like structure that transports proteins. It forms these very specific, complex shapes called minimal surfaces.
Minimal surfaces, like a soap bubble, always forms the smallest possible shape to hold air.
Precisely. Nature is lazy. It wants the most efficient shape to minimize energy. So the cell forms these, like, parking garage ramp structures. Now, zoom out, way out, to a neutron star.
The densest thing in the universe besides a black hole.
Right. And deep inside its crust, the nuclear matter protons and neutrons get squashed together under unimaginable pressure.
And astronomers call this nuclear pasta, right?
Yeah.
Because it looks like lasagna sheets or spaghetti.
They do. And here's the kicker. The topology of that nuclear pasta in the star is identical to the endoplasmic reticulum in the cell.
But how? I mean, one is squishy biology held together by weak electric bonds. The other is super dense matter held by the strong nuclear force and crushing gravity. The forces are completely different. The scales are cosmic.
And that is Coşkun's entire point. If the forces are different, but the result, the shape is the same, then the forces can't be the fundamental architect. The geometry is. The rose pattern, this tendency to form these randomly organized structural entities, that is the deeper law of the universe.
So he's saying we shouldn't be trying to chop nature up into little blocks of gravity or electromagnetism. We should be looking for these repeating shapes.
Yes, it's a move from a force-based view of the universe to a shape-based view. He's implying these minimal surfaces are the key to understanding everything. It's a geometry of reality that exists before the forces even come into play.
That idea of connectedness through shape, it bridges perfectly into the next part of the manifesto. Because if this geometry is universal, it shouldn't just be in stars and cells.
It should be in our minds, our art, our myths.
And this is where the text becomes a true meta-text. He refuses to keep science in a silo. He brings up this fascinating historical coincidence in Proposition XXV, the year 1911.
1911, what happened?
Two things. First, Wassily Kandinsky publishes his work on abstract art point and line to plane. He's trying to strip away realistic images to find the spiritual vibration of pure shape. Points, lines, geometry.
Okay, and the second thing?
C.T.R. Wilson invents the cloud chamber. It's a device that lets us actually see the trails of subatomic particles, cosmic rays passing through mist.
So on one side, an artist is drawing abstract lines to find truth. On the other, a physicist is capturing abstract lines to find truth.
Coşkun says this is not a coincidence. It's a convergence of mythos intuition, story, and logos reason. He writes, seeing a muon track in Kandinsky is seeing the stationary and the rotating as one.
He's saying the artist and the physicist were actually looking at the same thing.
Yeah, the fundamental geometry of reality. They just use different languages to describe it.
And he takes this respect for non-scientific knowledge even further. He talks about the Australian Aboriginals.
Proposition 730. Usually Western science dismisses indigenous knowledge as, just mythology, nice stories, but not real data.
Coşkun completely disagrees. He looks at the concept of dream time.
That's their understanding of creation, right? That the ancestors sort of sang the world into existence.
It's more than just creation. It's a complex understanding of time. In dream time, the past, present, and future are all interconnected loops, not a straight line. Coşkun argues that this actually aligns with some very advanced modern cosmology.
Like Roger Penrose's conformal cyclic cosmology.
Cosmic Ouroboros, yeah.
Yeah.
The snake eating its own tail. The idea that the universe ends, and that end becomes the Big Bang of the next universe.
Wow.
He's suggesting that these indigenous cultures might have understood the harmony and the geometry of the universe better than our rigid linear science does. We have the calculus, but they had the intuition. They saw the circle while we were obsessing over the line.
And speaking of Penrose, he ties this geometry right into our own brains. Proposition XD3 mentions the Orch-Orr theory.
This is a controversial but fascinating theory by Roger Penrose and Stuart Hameroff. It suggests consciousness isn't just neurons firing like computer switches. It suggests consciousness arises from quantum vibrations inside microtubules in the brain.
Wait, microtubules, that's the same structure he mentioned in the Rose postulate with the cell?
You're catching the pattern. It's all connected. The cell, the star, the brain. He suggests consciousness might be a resistance to quantum collapse, a topological phenomenon.
So we are geometry experiencing itself.
In a way, yeah. He links this to a concept from Turkish-English called yaşamdaşlık symbiotic existence. We aren't isolated observers. We are pieces of this topological puzzle.
It's a beautiful, holistic view, but then we have to come back down to earth. The current academic system doesn't reward holistic views. It rewards staying in your lane.
And this brings us to his most poetic and maybe his most tragic metaphor. Proposition XXY, the fruit.
I loved this. Walk us through the life cycle of an idea as a fruit.
Okay. So a new idea starts bitter. It's unpalatable. The establishment rejects it. This tastes wrong, they say. But then, through time, testing, the wind and humidity of logic, it ripens. It becomes sweet. It becomes accepted truth.
And we love the sweet fruit. We write textbooks about it. We teach it in university.
We do. But nature has a rule. Fruit must rot. It has to die, decompose, and fall apart to nourish the soil so the next seed can grow. Coşkun argues that modern academia is terrified of the rot.
We're trying to keep old theories alive artificially, pumping them full of preservatives.
He gets really specific about this with dark matter, doesn't he?
He pulls no punches in Proposition XXVIII. He looks at that lambda CDM model we mentioned. The math doesn't quite work anymore. Galaxies spin too fast, the universe expands too quickly. So instead of saying maybe our theory of gravity is wrong.
Or maybe the model is just rotting.
Right. We invent dark matter. We invent these invisible particles, WIMPs, axions, dark photons to plug the holes.
And we build multi-billion-dollar detectors to find them. And we haven't found them. Coşkun mentions his own experience, and this feels personal, of being excluded from a research school because he wanted to look at alternatives, not the fashionable particles.
So he sees the refusal to let the old model die as a betrayal of the scientific method.
Absolutely. We are hoarding rotting fruit and starving the soil.
Yeah.
We are so afraid of being wrong that we can't be right.
So what's the solution? If we stop being the toothless crocodile, if we let the fruit rot, what we become? This is his Ionian dream.
Proposition XXE7. He calls for return to Blue Anatolia.
He's referring to the geography of the ancient Greek thinkers, right? The coast of modern-day Turkey?
Yes. Thales, Anaximander, Heraclitus. These are the first physiologos. They lived on that coast looking at the sea and the stars. They didn't have grand applications or peer review boards. They just had curiosity. They tried to find the lodos, the underlying reason, in the chaos of nature.
Is he just being nostalgic, or is there a practical application here?
He wants a synthesis. He doesn't want to throw away our computers and colliders. He's a physicist. He knows we need them. But he wants to inject that Ionian spirit back into the machine. He wants physicists who are also poets. Rigor mixed with intuition.
And if we don't do this...
He believes science will enter a dark age. He actually ends with a warning about that darkness. Proposition XXD2 quotes Pythagoras.
Or a fictionalized Pythagoras from one of his stories, yeah.
Agiomikritos mi desicito.
Let no one ignorant of geometry enter.
But the warning isn't about failing math class. It's about a future where communication speed is valued over understanding. A world where the unworthy dominate discourse. Where we have information, but no wisdom.
That sounds uncomfortably like the timeline we're living in.
Mm-hmm.
Social media, 24-hour news, rapid-fire preprints.
It does. Pythagoras warns that a world disconnected from the deep geometry of nature leads to a darkened world filled with lies. Coşkun is telling us that the only way to turn the lights back on is to reconnect, to look for the rose pattern, to be the wolf, not the golden retriever, to understand that the shape of the cell is the shape of the star.
It's a heavy message, but it's an inspiring one. It changes how you look at a textbook, or even a star. It challenges you to think about whether you're actually thinking or just processing.
Absolutely. It forces you to ask, am I understanding nature? Or am I just memorizing the menu?
Well, there is a lot to chew on there, even for a toothless crocodile. If you want to dive into the deep end yourself, and we really only scratched the surface of these 40 propositions, you can find the full manifesto, Doda Üzerine ve Yandıma Karşı on Nature and Against Method, available at kitapurdu.com.
It's a challenging read, for sure, but if you enjoy having your worldview shaken a bit, it's worth it. It is a rare example of philosophy, hard science, and art criticism all rolled into one.
Definitely. And here's a thought to leave you with. If ideas are fruit, and they need to rot to birth the future, what belief are you holding on to right now that is long past its expiration date?
Let it rot.
See you in the next deep dive.